Hello, this is Sandy from MateSel, and I'm going to provide a brief introduction to MateSel to let you know what it is and how it might fit with your own operations. We'll look at what MateSel does, how MateSel works, provide a quick demo, and we'll finish off looking at who uses MateSel so you can see the range of application and how it might fit for you. So what does MateSel do? Well, MateSel helps you to drive your breeding program, and this can be an animal or plant breeding program. MateSel integrates all of these technical, logistical, and cost issues into a single decision framework so that you can accommodate a wide range of issues simultaneously when implementing your breeding program. It does this with a desired outcomes approach. So you set a target and MateSel chases it. And if you don't like where it takes you, you can move the goalposts in the light of these results achieved and move in this different direction. So you don't change the solution, you change the goalposts, and MateSel does the hard work of getting as far as it can in the new direction that you set. MateSel produces a mating list or crossing list that accommodates all decisions related to these issues. The classic way of doing this is to use a decision support system to work out sets of rules across the different regions of importance in your breeding program. And the practitioner has to accommodate these different sets of rules, and sometimes they're quite antagonistic with each other. That means that there's a lot of judgment required in making these things work together to come up with a set of actions. The approach that we take with MateSel is quite different because the software has as output the actions to be taken. You don't want to let the computer dictate what you're doing, so you are involved with your own judgment, experience, and attitude, creating a result that gives actions that you have ownership of because you've been involved in the development of the outcome. This is a highly complex problem that MateSel solves, and to achieve this, MateSel uses a mixture of different algorithms that compete with each other and also cooperate with each other to find solutions that fit your current objectives. Operation is interactive and flexible, and that's important because you can discover new directions and sometimes unforeseen directions as you're working with MateSel. In the end, you guide the analysis to a solution that you're happy with. Now we're going to run a quick example of MateSel in beef cattle. Let's consider that we need 100 matings from a population that currently has 40 male candidates and 108 female candidates. We also have the initial objectives listed below, and we call them initial objectives because your objectives may change during analysis in the light of what can be achieved. We want a strong emphasis on high genetic gain, a moderate emphasis on high genetic diversity. We want to reduce variation in birth weight, and we'll have a look at that a bit later as to why in the analysis. We want to target no reduction in average eye muscle area. And there are a number of reasons that might be, including marketing reasons that you don't want to be seen to be having a breeding program that is going backwards in a certain trait. We want to avoid mating carriers of a particular genetic condition, and we want to keep progeny inbreeding below a certain threshold, let's say 3%. And here's MateSel with our objectives on the right-hand side. We can open our own data files, but we're going to use the MateSel Classic demo that's packaged. Now, if you have launched MateSel from a Breed Society website, you'll be taken directly to this screen with the candidates that you selected within the Breed Society website, and the data source will be set to the name of your Breed Society. We won't be using grouping in this demonstration. However, if you were to have a quick look, you can see that you can group male groups and female groups and also control the mating between those groups. But let's go back and have no grouping. Now we're after 100 matings, and we could specify the maximum and minimum matings we're after for each male and female candidate. This tells MateSel that Wayne and the other sires can essentially be used up to 25 times each. We could also specify a minimum mating. So for example, if we put 20 here, that means if Wayne was selected within the mating list, that he must be used at least 20 times. Now, if you were to use the must use feature, this tells MateSel that it must absolutely include Wayne in the mating list for at least 20 matings. So this is a useful tool when you've got already purchased semen. So let's say that was 20 straws of semen. You would want to select this feature so that you're using all of those resources that you've got. For simplicity, we'll just run without any minimums, and we'll proceed to review our inputs and run the MateSel analysis. So you can see the solution has evolved along this path to this point here. Now, what does that mean? Well, let's look at the matings. This is saying that mate this male with this female. And if you make all of these matings, this is the result you will get. This is a graph of average progeny index, so we want to be high here, and parental co-ancestry, we want to be low here. So ideally, our solution wants to be as far into this top left corner as possible. But we can't get any further than this frontier that MateSel has calculated for us. This is the first decision we need to make, the balance between genetic gain and diversity. If we were to take an aggressive approach and go for maximum gain and show the latest mating solutions, you can see that there's only a few sires, the high indexing sires being used. So you can see there's 4 at the moment. If we went to maximize diversity and updated the target and showed the latest mating solutions, you can see that there's a lot more sires being used to deliver that diversity. In fact, you can see that there's 31 sires being used. So we'll just move this back to a more sensible level of 25 degrees and update target. Now let's look at these 2 trait objectives over here. If we have a look at birth weight, we can see that there are a number of low birth weight in the progeny, and that might not be good for the breeder in terms of viability of that progeny. And we've also got some quite high birth weight progeny. Now that could have issues with dystocia. So what we could do is we could come in here and select the decrease progeny variation option and apply that target. Now you can see quite quickly that what MateSel has done is it has pretty much topped and tailed the birth weight variation there. And it has done that with minimal to no compromise on your index. And that's because it's not changing the selections, it's more the mate allocations that are occurring in the mating list. The next trait to look at is eye muscle area. So you can see here with the black tick, that is the average of the candidates, and the red tick is the progeny average. So you can see with the current mating solution, we've actually gone backwards with a response negative 0.2. So what we want to do is we want to maintain our eye muscle area average moving forward. So we're going to select a set target for average progeny value, and we're going to select right on that particular average that we've already got with the candidates and apply a target. And so now you can see that on average, our eye muscle area within the progeny are going to be maintained. You can see that that trait target has made a small impact on our genetic gain, as it's a bit antagonistic with the selection index. Now back to all traits. Another control type we see used a lot in the field is using the maximum minimum limits on traits. So for example, if we saw IMF fat and we wanted to apply a minimum progeny value, because these might be out of bounds in terms of where we want our progeny to be, we can then apply a target for those, and we can ensure that the progeny that we have for this mating list are all going to have predicted values above that threshold. Now let's move over to having a look at the marker management tools so that we can avoid mating of carriers. Let's assume that with the M2 gene, the 2.2 version represents the affected individuals, and we want to ensure there are none of these. What we can do is we can select the average progeny value decrease option, and I'm going to put an extreme weighting on that to really push that hard. And when we apply that, you can see that we've now eliminated any affected individuals in the progeny. So you can see that that last target has also reduced our overall progeny index, as we've got 4 targets applied now. Let's now look at the last objective, which is the progeny inbreeding below 3%. Now, what we have here is the number of matings and the progeny inbreeding percentage along here. So we can see that we have some matings which are higher than in inbreeding than we want. So what we can do is we can choose to select a limit, and we're just going to find that 3% threshold there. Let's just say 3.08, and we are going to update the target. And you can see MateSel is slowly rearranging the matings to eliminate that. So if you find that they're not completely eliminated, what you can do is really push it harder with a higher emphasis. And there we go. We can now see that we should have no matings that result in a progeny inbreeding above 3.08%. And we can check that by going to the Matings tab, showing the latest mating solutions, and then sorting on the progeny inbreeding. So you can see that the highest inbred mating that we've got is 3.04%. So you'll see we've applied a number of targets to this breeding program, and that has come at a compromise to genetic gain. So we could moderate our ambition with these different components and get a better balance perhaps. For reporting, we have a number of dashboards that can be viewed during the analysis. And when you are finished with the analysis, there's a number of reports that you can download. So this comes under the analysis files. The mating list, summary detail, backup size, and also a PDF report with a summary of the run. This has been a simple demonstration of the basic features in MateSel, but of course we must cover a lot more ground than that to satisfy progressive breeding programs. So we do things like targeting multiple markets and regions, and cover unusual situations like mass spawning fish, and we use genomic information for a range of different applications. We won't go through all of the features listed here, but feel free to pause the video and read each one. We'll finish off looking at who uses MateSel. These are typically breeding organisations such as breed societies, service providers who are catering for large numbers of breeders, and universities. Universities are largely doing this for research purposes, but there's quite a lot of research going on in-house within breeding organisations where they're using MateSel to develop strategies that they adopt for their breeding programs. We have a wide extent of use in animals across all of the key species, and also things like insects and laboratory animals. In plants, we have an increasing use across a number of species, including trees, and geographically, it's widely used as well. Retention is good, and we're pleased that all groups that have implemented MateSel in routine operations continue to use MateSel. The MateSel user community is also growing, and that's bringing together a wealth of experience and expertise. So combined with its application across a wide range of species, this forms a great resource for further feature development. There are many other videos and learning material that you can look at to get further understanding of what MateSel does, and if it looks interesting for your operations, please feel free to ask any questions or ask for a demonstration. Thanks for listening.